So I hope you're all back now. I got a very good suggestion, which is that I could share the updated schedule with all of you. Um, so just imagine this happened before the first talk, and then everything is in order. So after Tom, I'll do a quick presentation on our Melody framework, which originally was planned not to happen because we had Sean planned in, but now I have to kind of do it. After that, we'll get our first talk from Tobias for Webpack, the past, the present, and the future. Afterwards, Norbert is going to introduce us to the story of Storybook. Then there is a lunch break. After that, Nadica and I will do a little quiz with you, just to ease you back into the day after the excellent food. I hope the food is good today, just saying. Then Berang is going to tell us about his first contribution to open source. And then we'll have Marvin talk about how to do more with less. Then we'll have a few lightning talks by Andy Grunwald, Jorge, and Matthias. Then Tobias is going to do the one thing that everybody will tell you not to do. He's going to live code at a conference. Just saying, it's going to be interesting. And then we have a special guest star here today, Pia from Open Collective, without whom none of our sponsoring would have been possible. And she'll introduce us all to Open Collective and what it is about. Then our own Ayush is going to speak about Veraccio together with Juan, who is here, I hope. Yeah, hello. Cool. And then we'll do another break. So plenty of breaks. Before Tobias is going to answer any questions you may have about Webpack. And I'm sure you have plenty. If not, prepare some. Live update. Good. Then we'll do a quick campus tour. And hopefully, I haven't asked them yet, but hopefully a few more people are going to join me and Tobias when we answer questions about open source in general. But we'll get to that later on. So that's the plan. I hope it works out. Questions or comments to the schedule? No? Cool. I should have used the break to figure out how to get speaker notes. Yeah. Tom, you know how to use Keynote, right?
Somewhat. I think you have to do the splits, not mirror the displays, but have separate displays.
Not really. Thank you. So little known fact, me and computers, we just don't get along really well. But yeah. So one of my primary jobs at trivago at the moment is to interview people. Interview people who apply for a position at trivago. And apart from them talking about how they love how we are engaging with open source and how they all look forward to our learning opportunities that we provide, like the relationship that we have with Carl Simpson and the workshops and events like today, there is one thing that you can be sure everyone is asking, which is why Melody? And by extension, why don't you just use whatever? And whatever means whatever that person likes the most in terms of frameworks. So I wanted to take the chance, kind of pressured by, Sean not being here, to tell you why. Yeah, so why Melody? Well, because web engineering is not easy, which every one of you is going to agree with, hopefully. Anyone who thinks it is easy? Cool, perfect. In the past, when I and some other people started with web engineering, it was mostly about writing HTML and some CSS. And then there was a sprinkle of JavaScript just to make the cursor blink or whatever, right? Just a little bit. And we were building mostly static websites. And some of you may remember that the question of, okay, how do I do this layout used to be just use a table. Anything else is not going to work anyways. And maybe we were using a few floats later on, but that was just a tiny thing, right? And the most important thing was use tables, because that worked, everything else didn't. And spacer gives. Well, things changed. And today, building websites is not really building websites anymore, not in the way that we used to do it. Today, we're building complex web applications, and they have a lot of state. They may need to sync state across different devices, different users, everything. You have client-server architecture. Things have gotten really messy. And over the years, unfortunately, as we got better in building more complex applications, our users also got used to those complex applications, and they kind of expect that from us, They want motivating and informative animations, they want transitions, they want smooth responses, You can't just wait for a couple seconds before you respond to the user. You need to do that immediately. And recently people started to expect that the web works offline. I mean, seriously, the internet works offline, and that's becoming a norm. So, web engineering isn't easy because this is a small recollection of what you actually need to know if you want to build a web application today. And I stopped after like 5 minutes or so. That list could have kept growing massively. And I obviously didn't write down any of the things that I don't even know about, right? So, do you think any one person can know all of that? Probably not, right? I mean, I can't. I can't know everything on that list. Some of it, but not everything. And then we also need to think about what it actually means to build large applications. Because when you're building a large application that consists of hundreds of thousands of lines of code that not just 2 or 3 people are working on, but rather 30, 40, 50, 100 or 200 people, then that changes the way that you're building applications. Single components are less important compared to how your data flows throughout your application. It becomes less important what something looks like. In detail, it is super important. But if you think about the engineering effort and the differences that each and every decision that you make have, then what a single component looks like is not as important as how you define the public API of an internal module that you're defining. How are other engineers going to work with the code that you've written? And overall, if you make a minor mistake, then that usually becomes a burden on the system stability and the flexibility of working with your code. I found this presentation recently, this image. It's from Yazan. Sorry, my contact lenses are not working well today, so I have to squeeze a little bit. Where he gave a presentation about how to use Redux and how not to use Redux. And I found this a pretty good example, right? If you're building a small, tiny web application, a to-do application, and you're the only person working on this, that is not going to be a problem. If you're building a large-scale application with hundreds of thousands of lines of code and 100 engineers, doing this is going to cause massive damage. So, apart from all of the things that we've seen before that were really related to web engineering, this is a short list, and it's, again, not complete. You can add more stuff here. A short list of the things that we all also should know about to build web applications that have nothing to do with web or anything like that. This is just software architecture. Just things that we should also know about. I'm not going to read that list, don't worry. But those things help you to work with many engineers on the same system. You know, they tell you how to structure an application for scalability. And they help you to write code that is actually reusable so that you don't end up shipping 2 or 3 or 4 or 5 megabytes of JavaScript to your customers. Because you don't want to do that. If you follow those principles, you will be able to ship less because you're able to reuse more. Now the worst part, you know, all those things were pretty old. We can read them in like real books on paper. But we're not done yet. The web is becoming more complex almost every day. Somebody is adding new stuff there. And if you want to be a web engineer, you better know all of this, right? Well, again, I don't think that's realistic. You can't know everything. You can't keep up with everything. But you should know some of those things if you want to deliver the best possible user experience. And a year or two from now, our users are going to expect us to know all that stuff. So, where does Melody come in? Well, we're not there yet, but this is another beautiful article that I found online by Chris from CSS Tricks, where he describes the Great Divide. Basically a specialization between JavaScript engineers on the one hand side and non-JavaScript engineers on the other. And what is nice about this, does that thing have a pointer? Is that the blue here, which represents one individual, can go in this direction and in this direction at the same time. So you don't need to fully specialize, but it kind of is, you get either really good in JavaScript or in the rest. And that is one way to deal with it. So instead of having one person who knows everything, or having many people who know a little bit about, you know, this part about, how to get pixels on the screen, but are experts in this part, you can actually have specialists. You can have people who excel and who exceed all expectations in the UI and UX engineering, and you can have people who focus purely on writing the JavaScript. And at trivago, when I joined in 2014, end of 2014, I was one of the first, if not the first, JavaScript engineer, but we did have UX engineers already. And over time, we actually embraced that. So we got more UX engineers, we got more JavaScript engineers. And those were two clearly separated job profiles and separated expertises and responsibilities. We work together very closely, usually on the same product, on the same component, but to each their own. Yeah, so this is another beautiful article that I found, or actually an image. And I took it from GitHub. I don't know where it originates from. Might be this one might be elsewhere. I have no idea. But it is quite a common picture, right? So one of the things that we keep doing recently as a web engineering community is we don't split things anymore by JavaScript, CSS, and HTML. Rather, we think about the entire component and we think, okay, this is one component and therefore one concern. And that means, of course, that how a component looks like and what state a component is going to encapsulate are pretty strongly coupled these days. And it's not just JSX. You could do the same, right, with Svelte and with many other frameworks. So it's not about that. It's about the mindset shift, right? Instead of having separate technology, we separate by component. So I don't look as old as I am, and I'm not as old as this will make me sound, but I have been around for about 20 years in software engineering, and I've learned a few lessons and I've seen a few more things than just web engineering. And one of those things that I've done over the years is build rather complex and rather large desktop applications using various frameworks. And when I look at separation of concerns and about how we want to focus on single components, then I can't help myself but to think about all the things that I've seen over the years, all of the other frameworks and what they actually do in terms of separation of concerns. So this is going to be another history lesson, but I will try to make it short. Java Swing was one of the first frameworks that I've ever used for building client-side applications. Java is this very old language. It's kind of like JavaScript, but doesn't have the script part, so it's not as much fun. And in Swing, everything was a component as well, because that's how you organize applications, right? You have components, and you use those components. But each component was made up of 3 parts. There was a model, there was a view, and there was a controller. And because nobody ever managed to get MVC working on the client side, it was a simplified MVC pattern. But we had those 3 concerns clearly separated from each other. And that enabled us to replace, for example, the view of a component. It enabled us to replace the model and get a completely different behavior out of a component. All those concerns were clearly separated. So we're speaking about open source today. I present to you one of my very first open source projects called the PGS Look and Feel. Yeah, I'm great with naming things, by the way. Which was a way to change how a Swing application looks. It replaced the painting logic, basically. And originally, when I started with Swing engineering, that was done using Java. So left-hand side, you can see the beautiful code there. And then over time, it became clear that there was a problem doing this kind of stuff with Java. Because up until recently, I have seen this code in production in banks. Okay, you should look a bit more shocked because I was a teenager when I wrote that. And what does it tell us if the code that a teenager wrote and open sourced is being used all over the place in large enterprise applications? Well, it means writing that stuff wasn't easy. It wasn't easy enough. Because to be able to do that, you needed to know what something should look like. You needed to have a little bit of understanding of designing things. You also needed to be an expert in left to right and right to left languages. You needed to know how to use the, Java 2D API, which is raw 2D drawing. And you needed to be pretty good with Java and with Swing. So to be able to do that, you needed to know a lot of stuff. And I can safely say that I'm thankful that I forgot all of it. But then in 2005, Sun Microsystems, which was back then the owner of Java and the Java framework, did this little thing in the top right. It's called the synth look and feel. So they tried to solve the problem of requiring people to have a lot of knowledge about things by introducing XML. Yeah, some of you are laughing, that's correct. Now they had 2 problems. But yeah, the idea was that by having a declarative way of defining how something should look, you would be able to do this even if you were not an expert in Java engineering. You would be able to do this even if you were not an expert in 2D graphics. And to a degree, they were right. So by moving to XML, more people were able to actually create those look and feels for Java Swing applications, and they stopped looking like this beautiful picture in the bottom right, which is the Matisse editor in NetBeans, which we use to build the UI of applications. So instead of writing the Java code to add something to a container and then tell it how to lay it out, what we were doing is we were just dragging that stuff, dragging it to the space where we wanted it to be, and then we wrote the actual application code, so that we didn't have to care about, how to structure that stuff. And even back then, even with XML taking over for how to render stuff, we weren't done. There were people experimenting with using XML to build the entire application structure. And there were people who were researching whether we could use CSS to do the styling of applications, because that would have made our lives much, much easier, and more people would have been able to contribute to our applications and to make them prettier. And then in 2006, WPF, the Windows Presentation Foundation, was released. There was a new framework for C# and .NET applications. And my first encounter with that was in 2010, when I joined a new company. And at that time, I had been working with many programming languages, sure. I also had dabbled a little bit with C# and with WinForms. But WPF I had never known about, and I was worried about it. So the CTO of that company during my interview told me that I need not to be worried about it, because once I knew WPF, he told me I would never want to use any other framework. He was right. I'm still sad that I can't use it at this point anymore, because it doesn't work for web. Well, there was Silverlight, but let's not talk about that. And you can see that in WPF, there's also components, and components make up the most of your UI logic. Unlike in Swing, WPF opted to use a different paradigm. So instead of MVC, or the simplified MVC that was used by Swing, WPF was built on the MVVM model. So it had a model, a view model, and a view. And again, view model and model separated, view model and view separated. And the way this looked was like this. So there is some C# in the bottom right corner. That was the view logic, the view model. And on the left-hand side, we can see a bunch of XML responsible for the styling. And on the top right, we can see another bunch of XML, which was used to describe the application structure. And in WPF, the C# code that was powering the components was called the code behind, because it was behind the XAML files. And we can see that just like the evolution that Java and Swing have taken, moving from painting stuff with a general purpose programming language, they moved to painting stuff with XML. And they took it a step further by removing all the general programming language code that was previously used to build UIs, and they made that XML as well, empowering more people to actually be able to do it, but also making tooling a lot easier. And then in 2007, Sun, or a Sun employee, released a new thing called F3. And that was a radically different declarative kind of language, not XML, for defining UI applications. And it was super powerful, using a weird scripting language that very few people ever learned, but it was really cool at the time. But it never caught traction. And then in 2011, it was released again, different. They no longer used their own programming language. They kind of used XML, you guessed it. And it was rebranded as JavaFX. And that, well, Oracle and stuff, but that kind of caught traction. And they adopted the same architecture that WPF was using. So they have a view model and a view, and those two make up a component. And the view model is binding to some model, whatever that is. And this is what it looked like. So it's Java, not C#. Therefore, there's more code. But you can see we have the same thing here again. We have the view model, which is just taking care of the properties that something should have, that the component should have. And then we're loading an XML file, which is describing the structure of the component and setting up some bindings. And then there is something new in JavaFX that they've added, which is CSS for styling. So the latest kind of like framework for building client-side applications before the web got crazy and everybody moved there, JavaFX was made up out of Java, XML, and CSS. Just saying. Why did we do that? Why did we have all those domain-specific languages like CSS, like fxml and XAML and whatever the word for the synth XML stuff was? Well, because domain-specific languages have a couple of advantages over general-purpose programming languages. And it's not just those frameworks, it's also stuff like Qt has its own QXML language, which is also, you guessed it, XML, and they have CSS as well for styling stuff. But why do they do that? Why do they all do that? Well, we've tapped into it before. By using a domain-specific language, you are able to focus more on the task at hand, and you remove some knowledge that you just don't need, you know? At least not for that specific purpose. And especially XML or XML-like languages make it easier to build automation, to build tools where you can just drag and drop stuff and you create a really nice looking application out of that. So it's more focused, it's more to the point, it's more expressive, it's easier to read, it's easier to debug, and you don't get null pointer exceptions out of it. Or for the JavaScript engineers, undefined is not a function. Yeah, that's my recap for my last 20 years. So I started out with building UIs in Java. Everything was in Java. That was horrible because, you know, lots of boilerplate. And then things got better because I got to use Java or C# together with some XML flavor, which allowed me to write less Java and C# code, which was great, and to have more declarative UIs there as well. And then I was building applications using Java, XML, and CSS, which was like amazing. Because for each purpose, I had a tailor-made language that was built specifically for that task. And that was great. And then I moved to the web. Well, I was doing web engineering before that, but my main focus shifted to the web. And it was okay. It was just the same, you know. I was writing some JavaScript. I was writing HTML and CSS. And of course, HTML is not XML, but it's close enough. And then we kind of shifted to writing JavaScript and CSS. And the XML or the HTML moved into the JavaScript. And then we're moving to a point where we're writing JavaScript. And that's it. Kind of like where I started, just with script added, so it's a bit nicer than before, and I don't have to, you know, generate interface and providers for stuff anymore. So it's better, but not as good as where we were before. And one side effect of that is that we are forcing people who are supposed to take care of styling things, of making them accessible, of making sure our code, our applications are indexable by search engines. We're forcing all of them to become JavaScript experts. Because everything we've done before, everything I've mentioned before about MVVM, about design patterns and architectural patterns, all of that is needed to be building those things. It's not just adding some styling there, it's more complicated. And the question is, does it really have to be like that? Do we really need to put everything in one file? Do we need to move back to where I started from? So, slide 19, now first mentioning melody. And I'll try to keep that one short because I suspect I'm running out of time. I'm not entirely sure. So what is melody? Well, melody is, as you guessed it, using an MVVM pattern, just like all the big frameworks out there. We have a view model, which we call the component function. We have a view, which in our case is a template. We're using CSS modules for the styling, and there is a compiler that transforms the template into currently incremental DOM instructions. That's kind of like, well, it's not like virtual DOM, but it does the same trick, just different and more complicated. And we connect that component, which consists of the view model and the view and some styling. We connect that to different models like a Redux store or like a GraphQL data source or whatever else we want, right? So same architecture as WPF and JavaFX basically. And then this beautiful view model or component function is basically a stream processor which takes updates and RX streams or observables. And it takes properties, stuff from Redux store, DOM events, render updates, whatever you can think of. Kind of mashes that together and produces and emits occasionally a view state, which is then being rendered. This is what it looks like in code. So the top right, there's a template. And that beautiful code is taken from our documentation. Did I mention I was not intending to give this presentation today, so I didn't prepare code and just copied it over. But if you're familiar with RxJS, then this will become very natural and you'll be able to read it. If not, then I'm really, really sorry. This could have been written much easier, but yeah, I didn't take the time. But it's basically, we take input, which is some events, some click events, and then we merge those together, and whenever somebody clicks on increment, we map that to a 1, and decrements are mapped to -1, and then we just do math, just plus. So that we can increment and decrement. We start with a 0, and then we return the state here. And whenever this emits, the state is updated, and the view is re-rendered. And the nice thing about that is that, like I said, if you're familiar with RxJS, then you have a really, really powerful tool that you can use to build your components. You don't need to take anything else into consideration. You just got one super powerful tool and you use it. And if you're focusing on building the UI UX of a component, then you get an equally powerful tool, which is a template language that makes it really easy and really nice to do just what you need to do. Is that actually true? Is a template language that much nicer? Do I need to say more? And this is just one example, right? So the benefit of the domain-specific language here is very obvious. I get special constructs like this for if we try to get that standardized in JavaScript, we probably wouldn't succeed. But it makes this code so much nicer, so much more specific for what we are actually trying to do here than the other version. So with Melody, we're trying to let the experts do their job, right? In 2015, when we had our JavaScript engineers and our UX engineers, we gave both of them free room to work in the way that is best for them. And we added a framework that would glue those two specialist groups together, that would enable them to work together on the same product, on the same project, on the same component in parallel, without forcing the tool of the one onto the other. Everybody got the tools that they wanted to use, that they were most familiar with. Our JavaScript engineers were able to focus on data flow, and our UX engineers were able to focus on things rendering the way that they were supposed to, learning and ensuring that we had a design system. These things. So JavaScript engineers focusing on software architecture and recently also server-side stuff, because just JavaScript, just streaming in our case. And the UX engineers focusing on semantic HTML, design systems, accessibility, SEO, and all those other things that are really, really important and terribly complex, and that you really need to get involved with if you want to do them properly. And that enables us to have JavaScript engineers who, during an interview, will scream, "Yes, I don't need to write HTML, CSS. Amazing. No, I finally don't need to remember whether I should use an article or a section for that." And we have UX engineers who don't want to use JavaScript. And that's fine. They don't need to. We still enable people to become more generalist. We still enable people and we provide them with support if they want to write JavaScript or HTML, CSS. And that's fine. But we also support people who don't want to do that, who want to specialize, because we can. And if we go back to this beautiful image on domain-specific languages, one of their benefits is that it's easier to port. And that means it's possible to replace one part of it with another, or you can change how it executes, what it's supposed to do. And in our case, in 2019, we replaced our component API to the beautiful thing that we've mentioned before, where it's Rx. Before that, it was mostly Redux. And in 2020, if I have it my way, I don't know yet, but maybe, we get to replace our incremental DOM with maybe Preact or something else. And then in 2025, without changing any code, we may switch that over to WASM or I don't know what yet, right? There's this amazing stuff that Ember and Glimmer are doing with a virtual machine, which is really, really cool. Because it's just a template language, we may be able to do that as well. I don't know yet. Maybe. Maybe we'll compile to Glimmer VM in 2025. Let's see. And we get to evolve our template language to accommodate our needs, right? When we started in 2015, like Tom said before, it was all Symfony, it was all PHP. We had to be compatible completely with Twig, which restricted our choices that we had at the time, which is also why I wouldn't, well, if you want to try it out, that's why you hate it, until you get used to it. But next year, maybe we get to finally make some cuts. Maybe we get to finally improve the language a little bit to make it more productive, to make it easier to use, because we don't need the PHP stuff anymore. And in 2025, I don't know, maybe it's built with space rockets. Who knows? So that's why. Hope you liked it. Just saying, in case you have become a fan, there's beautiful stickers, even if you don't like the framework. The stickers are really beautiful. And we'll put them over there. And now we have a break.